Hi, this is Nathan Tintle. In this Learning Goal video, we will talk about how to apply the 3S strategy to situations where we can do regression. We will use the GPA and non-academic hours spent outside of class data set to talk about this learning goal. The regression equation for this data is that the predicted GPA is 3.6 minus 0.0059 times the hours. Negative 0.0059 is the sample slope. That is, based on the sample of 42 students, what's the slope of the regression equation between these two variables? We wish to test the null hypothesis that there's no association between hours spent outside of class on non-academics and GPA. The alternative hypothesis is that there is an association. We've seen the 3S strategy before. The 3S strategy is statistic, simulate, strength of evidence. For the 3S strategy on this data, you can either use the slope or the correlation. We'll show the slope here. For the statistic, we use the slope, negative 0.0059. It's the slope that we observed on the sample. To simulate, we'll do the same thing we used for correlation. That is, we'll shuffle values of the response variable. So if you envision your data table with two columns representing the two variables, we're simply going to shuffle the response variable values and then recompute the slope on the simulated or shuffled data and repeat this many times, getting, say, 1,000 shuffled values of the slope. To evaluate the strength of evidence, we see how often we obtained our observed slope or more extreme by chance in the simulation. This will tell us something about the plausibility of the simulation, no association, as an explanation for the observed slope. A few words of caution. The 3S strategy here is the same one we've seen before. Statistic, simulate, strength of evidence. The way we simulate, no association, is equivalent to methods we've seen before and talked about in other learning goal videos. The main difference here is the statistic. We're using the slope instead of the correlation, or instead of, say, a difference in means or difference in proportions that we've seen in other chapters. Finally, this whole process leads to the exact same p-value as if we'd used the correlation coefficient instead of the slope.